Okay. Now, in this particular class, we will be discussing regarding the determination of elevation of an object. We will be discussing regarding the determination of elevation of an object when the base is inaccessible, and the instrument stations and the elevated object are in the same vertical plane. Okay. Now, this what is the meaning of this is, now we are going to measure this particular height, right? Height of this particular thing, right? When the base is accessible and the 2 points are in the same vertical plane. The 2 points are in the same vertical plane. When we are going to measure the height of this point, right? When its base is not visible, when its base is not visible and the 2 points are in the same vertical plane. They are in the same vertical plane, means they are in the same vertical plane, and we are going to measure the angle. Now, if the horizontal distance between the instrument and the object cannot be measured due to the obstacles, two instrument stations are used. Now, when we can, if the horizontal distance between the instrument and the object cannot be measured due to the obstacles, right? Due to the obstacle, when it cannot be measured, the two instrument stations are used so that the two instruments are in the same vertical plane as the elevated object. So here we are going to measure this particular height, right? And we are going to use the two instrument stations, and they are in the same vertical plane. Okay. Now, what we needed to do is set the theodolite at O1 and label it accurately with respect to the bubble, right? This is the point O1, right? We are going to keep the instrument, we are going to have the centering, leveling, and then we will be focusing, right? Direct the telescope towards, actually it is by mistake, it is written O2. Here we need to direct it towards the point F, right? Here we need to direct the telescope towards point F. From O1, you will be directing towards the point F, right? And clamp both the plates, read the vertical angle. We needed to clamp both the plates and we needed to have the vertical angle. So set the instrument, level it, center it, and then we are going to measure the point towards point F, and we will be noting down the angle theta 1, right? Now the vertical angle, this theta 1 is nothing but the vertical angle from point O1, right? Now transit the telescope so that the line of sight is going to be reversed and mark the second instrument station O2. Now what we are going to do, instead, now here we are going to transiting the telescope. From here we will be looking towards the point O2, right? And then we are going to locate the point O2 on the ground. So it is in the same vertical planes, mean that they are in both the instrument O1 and O2 are in the same line. They are in the same line. Measure the distance O1 and O2 accurately. Now this distance between the O1 and O2 is going to be get measured. Repeat the steps 2 and 3, right? This step and this step are going to be repeated both for the phase observation, and the mean should be calculated. Now, with having the vertical set reading 0 and altitude bubble in the center of the run, take the reading staff kept at the benchmark. Now here we are going to shift the instrument over here. Now what we are going to, after shifting the instrument, we will be noting down the benchmark reading. Here we are going to have the benchmark reading. Now shift the instrument to O2 and set the theodolite and measure the vertical angle. Now here we are going to set the instrument over here, and we are going to look towards the point F, and we are going to measure the angle, the vertical angle theta 2. Both are in the same line. Since we have done a transiting, they are in the same vertical plane. Okay. With the vertical vernier set at 0 and the altitude bubble in the center, take the reading on the staff kept by the nearby benchmark. So here also we will be taking from here to here also we are going to take the benchmark, and here to here also we are going to take the reading. So this particular distance also we will be knowing it. So V1, by keeping at V1, we will be noting down the angle theta 1. Then we are going to transit the telescope, and we will be locating the point O2 and measuring the distance between O1 and O2. Then we are going to have the staff over here. We are going to have the staff reading from O1. Then we are going to shift the instrument at O2. Then we will be looking towards the point F, right? We will be looking towards the point F, and we are going to measure the angle, vertical angle theta 2. Then we will be noting down the staff reading at B. Okay, so this is what we have done. Now, right, we will be noting down the angle and distance T. Now, let H is equal to FA. This horizontal distance, right, this vertical distance is nothing but FA, right? Now, next is theta 1 is the angle from O1 to F. You already know it, right? Theta 2 is the angle of elevation from O2 to F. S is the staff reading, right, kept on the benchmark, right, taken from both O1 and O2, right? You have kept the staff over here, and you have done the staff reading, right? You have kept it and you have taken the staff reading. D is nothing but the horizontal distance between this small d is nothing but the horizontal distance between O1 and O2. Larger D is nothing but the horizontal distance between O1 and F. This bigger D is nothing but the horizontal distance between the object and the instrument station O1. Right? From the triangle O1 AF, right? O1 AF, right? This H you can calculate it by using the formula. H is equal to d tan theta 1 from O2, right? You can calculate the distance, right? From this you can calculate this particular height. That is, you can calculate it by d plus d tan theta 2. You already know it. So d tan theta 1 is equal to small plus bigger capital D into tan theta 2 divided by tan theta 1 minus tan theta 2. Okay, so here you can, this is how you can calculate the distance, right, between D between the O1 and the point F, right? So d tan theta 2 divided by tan theta 1 minus tan theta 2. Now H is equal to d tan theta 1 can be given by the height H can be given by d tan theta 2 into tan theta 1, because H is equal to d tan theta 1 can be given by d tan theta 2 into tan theta 1. So this is how you can calculate the distance, right? Between O1 and F. Now, the this particular height, right, what we are going to do, we are going to have the staff reading plus, right, we are going to have the benchmark plus staff reading plus we are going to calculate this H. Then we can get to the RL of the point F. Is it clear? Yes, is it clear?
Yes, sir.
Okay, fine. Simple it is. Just we are changing the, we are going to use the two instrument stations. Now we will see, we will be solving one more problem, right? We will be doing one more problem, right? With having the instrument axis at a different level. Here, what is happening is the line of collimination or your horizontal line of sight. Here, the level of both the instruments, it is going to shift, right? Here, the level of both the instrument, it is going to shift. Okay, so this is how we will be solving the problem by the other type, right? Instrument axis at the different level depending upon the terrain, the different cases are there, right? Now here, the instrument axis at O2 is higher than the O1. Here, the O2 is higher than O1, right? O2 is higher than O1. The first case is when the instrument station O2 is higher than the point O1. So this is the first case we are going to have it. Okay. So here we will see, right? Now again, we are going to, in order to read the angle, we will be having the same formula, same procedure we are going to use as we have done in the previous thing, right? With when we are going to use the two instrument station, the same procedure that we are going to follow in order to take down the readings. Now we will see how we can measure the distances, right? Now, what is this theta 1 here? It will be higher because you can see that the higher difference of angle is there, right? Here the theta 1 is larger, right? Theta 2 will be smaller, right? So O2 is higher than O1. So D is nothing but the distance between O1 and O2 and this larger distance between O1 and F, right? So this is the larger horizontal distance. H2 is nothing but the difference in height between the line of communication and the object, and H1 is nothing but the difference in the angle elevation between the object and the line of illumination. This S1, this is your S1. S1 is what? The staff reading taken from O1 towards the benchmark. This is your S1, right? S2, here your line of illumination is over here. So you will be taking the reading over here. So difference between S1 and S2 will be the S. The difference in the line of illumination, right? Or difference between the two instruments is S. Okay, the height difference between the two instruments is the S. Okay, now H1 and H2 is we already know that this is equal to S, right? From the triangle, we are going to have d tan theta 1 from the angle again from theta T2, right? The height to H2, right? This is your H1, right? This is your H1 and this is H2. You can calculate it by d plus d tan theta 2, right? And the difference in the height between the two, we can measure it by having the difference the difference in the between the two instruments, right? D tan theta 1 minus theta 2 minus small d. So we can measure d will be common. So d into tan theta 1 minus tan theta 2 minus d tan theta 2. So if we simplify, here there is some change over here. Instead of d, we can have the difference between the distance between the object O1 and F, right? The object and O1 and F, we can determine it by using the formula. There's a slight change is there over here, right? We will be using the formula, right? D is equal to S plus D cot theta 2 into theta 2 divided by tan theta 1 minus tan theta 2, right? So this is the formula that we are going to use. This is the only small change we are going to have, right? So if we want to measure the distance d, right, we will be using the formula, right? S plus d cot theta 2 divided into tan theta 2 divided by tan theta 1 minus tan theta 2. So you need to remember this particular formula in order to solve the problem, right? So H is so overall height, right? The overall the RL can be given as the RL of benchmark plus S1 plus H1. Okay, so here we will be seeing, right, RL of BM plus S1 and H1. So if we want this particular height, RL of benchmark plus S1 plus this particular height H1. So if we want the point F, right, benchmark reading plus your S1 reading plus H1 reading. So this is how we will be solving the problem. Okay, so we will see how the problem can be solved, right? There is a two more cases are there that we will be seeing. Okay, in the when we are going to solve the problem, most of the things will be clear to you. So we will solve the problem, right? So we will be solving the problem, right? We will straight away move to the problem. Is it visible properly? Yes.
Yes, sir.
Okay. So we'll solve one problem, right? In order to ascertain the elevation of point Q, of top Q, right, on a hill, the observation made from the two instrument stations P and R. If in order to have the Q, right, the observations were made from the Q and from P and R. In order to read this Q, right, the observations were made from P and R. Next is the horizontal distance between P and R is, this horizontal distance between P and R is, it is 100 meters. It is 100 meters. So I have not written it over here. The distance between P and R is 100 meters. Right. The stations P and R are being lined with the Q. So station P and Q, right, are in a line with each other. They are in a line with each other. The angle of elevation of Q at P, right? The angle of elevation at Q, right? The angle of elevation at Q and P, right? Where, right? 28 degree, right? 28 degree, right? And at P it is 18.6. So here, right? Here the from P, right? From P, just a minute. From P, right? From P and R, there is a mistake over here, right? There is a mistake on from here. It is P and R. It should be P and R. So at P, right? So the angle of elevation at P is 28 degree 42 minutes. When you look from P, right, the angle of elevation is 28 degree 42 minutes. And when you look from R to Q, the angle of elevation is 18 degree 6 minutes. The staff readings upon the benchmark elevation, right? The staff reading, right? The upon the benchmark is 287.28, right? Respectively, right? And it is 2.870 for P, right? The staff reading was 2.870 for P, right? And for Q, it is, for R, it is 3.750. For R, it is 3.750. When the instrument was at P and at R, the telescope being horizontal, right? Determine the elevation of the foot of the height, right? If the signal is above the base, if it is 3 meter, this height is 3 meter. So what we want in order to measure this particular height Q, right, from P, right, from P, we want to determine it from P and R, right? So we will see this category, it falls under which condition, right? Can anybody tell me? Just now we have discussed few points. It falls under case 1 or case 2? Yes. Can anybody tell me it falls under which condition? Just now we have discussed the 2 points, right? The 2 cases. The first case was, I will just repeat it. The first case was, yes, yes.
Case 1, sir.
Is it case 1? This is
Yes,
what the
yes,
case 1 we have discussed. Is it case 1?
yes, sir.
Arey Baba, this is case 1. See, determination of elevation of object when the base is inaccessible, the instrument station and the elevated point are in the same vertical plane. That if there is no difference in height between the two instrument stations, but if you look towards the problem, right, here one angle is higher, one angle is lower, right? So one angle is giving you 28 degree 42 minutes, one is giving you 18 degree 6 minutes, as well as you can see the staff readings. Staff readings for one is, it is 2.87, and for one is 3.750. Is it a first case?
No, sir, second, sir.
No, sir.
It is second case. It is the second
Second.
case. Now we will see what is the second case, right? Now what is happening in the second case? Instrument axis at O2 is at the higher than O1. See, here you can see that O2 is at a higher level than O1. Okay, so this problem will fall under which category? Yes?
Second.
Seconds.
Irshad, which category? Is it second or
Second, sir.
first category? Then you are telling
Second
it,
case,
it
sir.
as first. Yes. Okay. So here what is happening is, here the point O2 is at a higher than the point O1. So it falls under, this problem falls under the category 2. Okay. Now elevation of the instrument axis at P. how we can determine the elevation, this particular point, the line of culmination, how we can determine is the RL of benchmark, right? The RL of benchmark plus the staff reading, right? Plus the staff reading. So here the RL of benchmark is 287.28 plus staff reading is 2.870. So here the RL of point P is 290.15 meter. Is it clear? Is it clear? Yes.
Yes, sir.
At first point, what we are going to do, we are going to determine the RL of point P. Now, how your RL of point P or your line of culmination height you are going to get? Benchmark, that is 287.28 plus the staff reading 2.870. So we will be getting the line of culmination at P, the RL of the instrument axis at P we are going to get. So it is 290.15. Similarly, we can calculate the RL of instrument axis at R we are going to calculate. So how we can determine it? We can determine it the RL of benchmark plus this particular reading. So staff reading. So 3.750. So here it is 291.03. So is it clear?
Yes, sir.
Yes, sir.
Yes,
Next
sir.
is, yes, okay. Now difference in the instrument axis, difference between these two instrument axes, how we can determine it? So 3.750 minus 2.870. So difference between these
Instrument
two
axis,
instrument, yes. So we can get it as 291.03 minus 290.15. It is equal to 0.88 meter. Now the angle alpha 1, we can have it, right? Angle alpha 1, we can have it by using the formula 28 degree 42 and alpha 2 is 18 degree 6 minutes. Now, if we want, right, S cot alpha 2, but why we want S cot alpha 2? Our formula says if we want to measure this particular distance, we will be using the formula D is equal to B plus S cot alpha 2 into alpha 2, right? Divided by tan alpha 1 minus tan alpha 2. So this particular formula we needed to remember. So according to, if we substitute this in the formula, right, we are going to get 100 plus, right, 2.69 S cot alpha 2. If we solve it, right, we will be getting 2.69 tan alpha 2. Tan alpha 2 is tan 18 degrees 6 minutes. So if we solve it, we are going to get this horizontal distance as the 152.1 meter. So H1, how we can calculate H1? This particular height H1. H1 can be calculated by using the formula, right? D tan alpha 1. We can calculate by using the formula D tan alpha 1. So we are going to get H1 as, right, D tan alpha 1. So 152.1 tan 28 degree 42 minutes. So D tan alpha 1 will be 83.264. Now the RL of the foot of the signal, right? Now we will be finding the RL of the instrument axis at P, right? How much is the difference, right? This difference we are going to find out, right? The RL, the height of Q from the point P, we are going to find it out. So how we are going to do it? We are going to find it out. The RL of instrument axis at P that we have already calculated plus this height H1, right? We are going to calculate the height H1, right? Minus height of the signal. So here it is, the RL of the instrument axis P, we have already calculated it. It is 290.15. H1, we have determined it as, right? H1 D tan alpha 1, we have determined it as 83.264 minus staff reading. Here we want the reading at the point Q. So at the base, here we want the, in order to ascertain the elevation of point Q, what we are going to determine here, determine the elevation of the foot of the signal. We want the signal at the foot. So here we have taken the reading at this particular point. If we want the reading at Q, we are going to reduce minus 3 because this height is minus, it is 3 meter. So here we are going to reduce the minus 3. So we are going to get the answer as 370.414 meter. So this is the RL at the point P. Now, the RL of the foot of the signal, right? The RL at the foot of the signal, right? So here, what we want, right? From this particular point, what is the difference in height at this? So what we are going to do now, RL of point R, then we want the height of this. So what is the RL of this line of collimination is height. The line of collimination height that we are going to have is 291.3.03 plus what we want, plus we are going to calculate the d tan alpha 2. So we are going to get it as 82.396 minus point minus 3. Okay, so this is how we are going to get the answer. Is it clear? Is it clear?
Yes, sir.
Yes. Is it clear? Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay,
Yes,
fine. Okay. So here we are going to finish the first part. Here I have skipped one particular part, that is here I have not calculated at this point, right? Before this point, there is a one more part will come. So B plus D, here what I want to calculate, H2 is equal to B plus D tan alpha 2. So here the distance I need to calculate, that is B plus D. B plus D is how much? B is 100, right? B is 100 plus this distance we have already got it as 252.1, right? We have got it as 252.1 over here, right? So this one here it should be 252. Sorry, by mistake I have written it as 151. It should be become 252.1. So here 252, right? D plus D tan alpha 2. So 252.1 into tan theta alpha 2 is 18 degree 6 minutes I have to write, right? Then I will be getting this particular answer. One step I have skipped from here. Okay, is it clear to you all? Is it clear? Yes. Is it
Yes,
clear?
sir.
Okay, what I have skipped is B plus D. I need to calculate this particular height. So B plus D tan alpha 1, I have skipped it. That's it. I want this particular thing, which I have not done over here in this particular part. I have missed that part. Is it clear to you all?
Yes, sir.
Okay, can I go ahead? Can I go ahead? Is the problem is clear? Yes. Problem
Yes,
is
sir.
clear to all? Okay, can I go ahead? Actually, I need more time in order to discuss this particular thing. But again, we will do it. We will finish it off. Right, we will finish it off. I wanted more time, but we will finish it. I think I want more time, so I may not able to, even though if I finish it, right, in this particular class, I will not be able to complete the problem, because the problem and this has to go hand in hand, right? So what we'll do? What we'll do? Yes, we will continue in this class, the theory in this class and problem in the next class. What we'll do? Tell me. Or both together you want? Irshad,
sir.
what we'll do? We'll take the case now and problem in the next class, or what we'll do?
So next class problem, sir. This class only theory.
Okay, theory. So shall I continue this theory also of the second case?
Yes, sir.
Okay, then we'll have this theory then, and we will be going to the problem in the next class. Now, next condition is, we have seen when the instrument is at the different level, right? Now, what we'll do is, when the instrument axis, right, vary at a different levels, right? If the difference in the elevation S2 and S1 between the two instrument station is too large and cannot be measured at one staff on a staff at the BM, then following procedure is going to be adopted. See here, this is the instrument station is at one height, right? And this is at the another height. So this staff reading, we cannot take it over here. So at that condition, what is the procedure that has to be followed, right? That we will be seeing, that we will be seeing, right? We will see it. Now set the instrument at O1. Here we are going to set the instrument at O1. Then what we are going to do and measure the vertical angle at F, right? That is theta1, we will be noting it down, right? Transit the telescope and establish the point O2, right? We are going to transit the telescope and we are going to establish the point O2. Then observe the staff reading R on a staff O1, right? Then we are going to observe, we are going to fix this position and we are going to have the staff reading, right? O1. We are going to have the staff reading, right? We are going to have it at O1. Okay. Then right, O1, let the S be the difference in the elevation at the two axes at O2. Therefore, S is equal to, right, the difference in the staff reading, S is equal to, right, here also we are going to have the S. Here from here we are going to take the height staff reading. Here we are going to take some height. Okay, here we are going to have the staff and we are going to have the staff reading, and O2 we are going to have one more staff reading. So difference between the two readings, that is S, the difference between the two line of collimination is S. Okay, so S is H2 is equal to H1. So D is equal to D tan theta 2 minus S. Okay, now the distance D, how we can measure it? So we can measure it D tan theta 2 minus S divided by tan theta 1. Okay, so here H1 can be given as this height H1 can be calculated, right? This height H1 can be calculated by using the formula, right? D tan theta 2 minus S into tan theta 1 divided by tan theta 1 minus tan theta 2. This particular thing we need to keep in our mind in order to solve it. Okay, D also we should know, this D also we should know, and this D can be calculated by using the formula D tan theta 2 minus S divided by tan theta 1 minus tan theta 2. So H1 can be calculated, this height H1 can be calculated by using the formula, right? D tan theta 2 minus S into tan theta 1 divided by tan theta 1 minus tan theta 2. So O2 can be calculated, this height, the O2, the angle O2 can be calculated, the height of the station O1 above the axis O2. Okay, it can be calculated by using the formula, right? By using the formula H is equal to, right? It can be calculated D tan theta minus R. Height of the station O1, height of station O1 can be calculated by using the formula, right? D tan theta minus R. So S we can calculate it by using the formula, right? D tan theta minus R plus H1. So what is H1? H1 is this. So this is nothing but the difference in between the two instrument stations. So it can be calculated by using the formula S, can be calculated by using formula D tan theta minus R plus H dash. So what is H dash? H dash is nothing but this. Okay. So here we can calculate it by using this. Now the RL of F, hence the RL of F is, we can calculate it by the RL of benchmark, right? The RL of benchmark plus here height of the station, hence RL of F, right? RL of F means we want the RL of F. How we can calculate it? By using the formula S is equal to RL of BM plus S1. Now what is S1? RL of benchmark plus S1 till this particular height. Then we will be calculating this, right? Plus S, right? Plus H1. H1 is we have calculated. How we can calculate? We can calculate the H1 plus this. So this benchmark plus S1 plus this S plus H1. So we can get the solution for this. Okay, so RL of BM plus S1 we already know, plus S, how we can calculate it? D tan theta minus R plus H dash plus H1. So this is how we can calculate. Now there is a one more, in tomorrow's class we will be solving one more thing, but here the problem based on this particular thing we are going to solve in tomorrow's class, and as well as we are going to solve the double plane method, right? In the double plane method also we are going to solve. So here you need to remember the formulas when we are going to solve the problem. So this is what the formulas is, right? This is what the formulas that we are going to solve in the tomorrow's class. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
You need to follow the textbook BC Purmia also if you want. Right? This is not that easy. If I tell it once, right? If I tell it once, it is not easily. It can be understood, right? If you are refer the textbooks also, if you are getting any doubts, then you can ask me, right? Have you understood what I have taught in today's class?
Yes, sir.
क्लियर इरशाद?
Yes, sir.
क्लियर है?
Yes,
क्लियर
sir.
है?
Yes.
Yes, sir.
इसके साथ साथ आप लोगों को टेक्स्ट बुक भी रेफर करना पड़ेगा. यू नीड टू रेफर द टेक्स्ट बुक, राइट? So the things are clear. Say it is completely based upon your trigonometry. The things are clear, but you need to follow the textbooks also in addition to the classes, right? I think I have circulated the notes in the group or no? Yes,
Yes, sir. Separated.
circulated. So in addition to that notes, see that notes might be all the things may not be covered, right? So you need to have the textbook. Do you have BC Pune textbook with you all?
No,
No,
sir.
sir.
Okay. Then possible what I will do is I will have these problems, right? I will scan it and I will send you in your groups, so you can refer it there also. Is it clear?
Okay, sir.
Fine. We will end the session over here.
Yes, sir.
Fine. We are going to. If you have any doubt, please ask. Let me ask. If you have any doubt, please ask.
No, sir. No doubts.
Okay. Are you happy with the things are going on? Yes.
Yes, sir.
Okay. इरशाद, सही से चल रहा है क्लासेस? इरशाद, कुछ
सर.
प्रॉब्लम है तुम्हारे? ठीक तरह से चल रहा है? समझ रहा है या नहीं आ रहा है? समझ में आ रहा है या नहीं आ रहा है?
समझ रहा है सर.
ठीक है, ठीक है. We are going to end the session over here. Shruti Naik, do you have any doubt?
No, sir.
Okay, fine. We are going to end the session over here. Thank you.